couple of announcements for this week, and actually, the question about what was coming up next week is a good one, because I just wanted to remind everyone that next week and the week after is Easter break, so that means our next live session will be the 22nd of April, which is kind of how we would have done it in normal circumstances anyhow. If you have any questions, I'll be available via email over Easter break. So, like I was saying, most people I have seen, I checked into who had completed so far last week's assignment, and most... You may want to mute your microphones. And most folks have had a good start on the assignment. Just be sure to finish that up. And that's also, I know I sent out a note earlier based on the 4-week extension. So what we're going to do, just to keep the class moving at a reasonable pace and as normal as possible, is we'll still have the weekly assignments. And I would definitely recommend carrying on with the weekly assignments each week, because it'll be easier when we're doing the live material to then go back and practice it while it's still fresh in your mind. Of course, like Hannah was saying, you can go back and take a look at the YouTube video if you need to, but you do have an extra 2 weeks of flexible time to get in those weekly assignments, just in case for any reason, you need a little bit of extra time. That's fine, there's no penalty to that. But do make sure that you get them in, because beyond those 2 weeks, I can't accept anything late because I release the answers and all the feedback on it. So what we'll do today is I want to have a discussion about t-tests. The descriptives will make more sense when we go through our data, and it's just, what's the average or the mean, those kinds of things. But on the t-tests, in terms of seeing their function, it's kind of helpful to have a little bit of background before we get into the data on them. So remember from your readings that, just so that we are all clear, the mean is one of the tests for what's the middle point. If you want the actual middle point, like you'll hear a lot of times people refer to median incomes, for example. And that's genuinely the middle income of anyone within a given population. The mean we're talking about is the average. So just like, when we're talking about your homeworks, for example, that's the average or the mean of your performance on the works. So just make sure that you keep those kind of vocabulary things in mind. So what the t-test's function is to ask, is there a significant difference between two averages? So obviously you want to be comparing likes for likes. But so as we go through, what was this one? That's how it's going to work. So it's the analysis of continuous data to identify differences in the mean. So continuous data, think of it like a scale. Let me get Tess in just a sec. Apologies, that's all. Come on. There we go. So when we're looking at the continuous data, that could be anything like a rate, a 1 to 7 or 1 to 10. It could be age. It could be income. So anything where people might report some number. It can be something within a scale, so bounded between 1 and some other number. But it could be literally any number that could come up that's referring to speed, to anything that goes along a continuum. That's a lot of times we're working with that kind of data anyhow. When your people are asked, on a scale of 1 to 7, do you like something? Or tell me your age, or any of those kinds of basic questions that where the number actually represents something meaningful. There's a difference between someone who is 10 and someone who is 20. The other kind of data, categorical data, we'll talk about more next week, but that's like gender. So gender, I might assign a 1 to male and a 2 to female, but there's no reason for it. Those numbers could have easily been changed up. So categorical data assigns numbers to categories, but the number itself doesn't really mean anything. So t-tests are always using scale or continuous data. So then it asks, is there a difference between those two comparable means? So it assumes that there's the scale data, and it assumes similar measures. Now the third one is this normal distribution of data. You guys have probably all seen a bell curve. What we would expect with you take a whole bunch of data is that somewhere in the middle will be the most answers. So if you think about what you might expect in terms of a normal population, you would expect the majority of people to be alive somewhere in the middle of the age range of people's life expectancies, from 0 to, I think the current life expectancy for most folks is like 78, something like that. Most people should be somewhere in the middle. That's a normal distribution of data. That's why it's called a bell curve. So there's fewer people, it goes up to the most, and then it comes back down again. However, you can have data that's skewed. So for example, I know Scotland has an older population. So instead of being a perfect bell, to say that it's skewed would mean that there's still a curve. It's just that instead of being in the middle, at the peak of the curve, it's to one side or the other. Now, the test will still work if you don't have perfectly normal distribution of data, but there are probably going to be some problems in terms of the comparisons that you make. It's not something too much to worry about for now when you're starting into, but it does ask the question of how well does your data represent the population that you're actually interested in. But so let's think about this in sort of a sensible commercial and actual kind of context. And yes, I thought that choosing beer comparisons probably would be a good idea. So the question that one might ask, let's say you're working for a small microbrewery. Do consumers like the taste of our microbrew more than our main competitors? That's quite a sensible kind of question to ask. And rather than having a raw percentage saying 52% prefer our taste to Bud Light, it's interesting, but it's not particularly meaningful. If you're trying to build a strong case for where your markets are, who you should target, what are the instrumental areas of growth, and so you're putting money into the promotion of a product or a service, you probably want to have more than just a general sense of what the majority of people think. That's not a particularly precise way to think about it. So you're trying to ask questions that are more detailed so that you can more reliably know where the most return on investment is. So this is a really typical kind of consumer-oriented question. So if we gave 1,000 people a questionnaire and said, here's a taste of, say, a Pilsner, since that's the Pikeland Pilsner, since that's a comparable kind of beer to Bud Light and Coors Light. Now rate your taste of each one of those on a scale from 1 to 7, where 1 is that you really don't like it and 7 is that you really do. Well, in our case, we had 1,200 people that tasted only one of the beers, the Coors Light, the Bud Light, or the Pilsner, and then they rated the taste based on the overall taste, how refreshing it was, the smoothness. So 3 separate questions. So last week, where we talked about how to create the factor, ran the factor analysis, and it resulted in this taste factor that ultimately had a Cronbach's alpha of 0.81. So just a quick refresher from last week, remember that a Cronbach's alpha of 0.7 or above is considered a reliable a reliable variable or a reliable factor. So we have a good taste factor when we're comparing these three beers. So that's our first step. What we did last week was our first step. We have our results from this week. Now let's see how they all come out. So the means, or the averages on the 7-point scale, show that in fact Pikeland Pils was more favorable, had a nicer taste, with a mean of 5.27 compared to Coors Light and Bud Light. So if you think about a 7-point scale, one of the tips in creating questionnaires and surveys is you want an odd number because then it has a genuine midpoint. So if you think about this 7-point scale, you have 1, 2, and 3, 4, 5, and 6, and then you have the 7. So you think about the 4 as sort of a midpoint. 3.5 to 4 ends up being a nice point in the scale. So Coors Light and Bud Light, people like them okay, but the Pils actually is quite nice, according to what people said. What we don't know is if that's significant or not. So right now we're saying, a lot of people like it. But we want to make sure that before we spend money and figure out how we're going to spend money, is significant enough to say that this is the preferred beer. So if we run our t-test, the purpose of a paired sample t-test is to make a comparison. Now the t-test only compares two means at any given time. So let's take a look at this table. The left-hand side that says variable is beer taste favorability. That's our combination of those three factors. Then, if you take a look at this, you can put a sheet of paper under the first two, Pikeland and Coors Light, because that's the first comparison. So, if you go over to the mean column, what the table is telling you is that it's comparing the 5.27 to 4.82 in order to determine if there's a significant difference. The standard deviation tells you how much people varied. It's something you report, but for the most part at this level, we don't worry too much about it. Now, the t-value is your test statistic. So different tests have different names for them. When we get to the ANOVA, it will be an F test. A regression is an R test. It's a little more complex. We'll get there. But so those are the basics values. The value itself doesn't tell you anything in terms of whether it's significant. That's just the value, and it can be positive or it can be negative. But how we know whether it's significant is when we look at the p-value. The p-value, or it's called the test of significance, tells you how much confidence that you can have in whether or not the number that comes up in the test statistic, the t-value, how much confidence that we can have. What you're looking for in a p-value is a number less than 0.05. So a 0.00 is well less than a 0.05, so that means that it's significant. When this is calculating it, what we're trying to say is this difference, is this something we could expect over and over? So if I ran this test again, is it just chance that these two means were different? Or is there a clear way to predict that if I took another 1,200 people, that the test could be replicated and to the same result? This calculates it within 99.5% confidence. So this is why when you see this kind of a statistic and you say that there is a significant difference, that you can have a lot more confidence. 52% of people liking something doesn't tell you whether that's going to be the case next time or if that's a meaningful value. So this is the difference between a poll that reports 42% of people like this. 70% of people, for example, think that the government's doing a good job responding to the COVID. It's a snapshot, but it doesn't tell you that there's a meaningful comparison. So this is why we want to make sure that there's always a significance. So we look for a number less than 0.05. So we come down to our next test, the Pikeland compared to the Bud Light. 5.27 mean versus the 4.79. Now, we can reason without looking over at the p-value that the 4.79 is lower than the Coors Light figure, so we would expect that to also be significant. And we look over to our very right-hand column, and it is. But then, just to make sure, what our final comparison is Coors Light versus Bud Light. People rate those pretty much the same. So there isn't a significant difference in how well people like the taste of Coors Light or Bud Light. And we know this by looking at our p-value, and it's a 0.76. So not only is it not significant, it's really not significant, because that number would have to be 0.05 or lower. Does that make sense to everyone? With no questions? So then the question is, what do we do and how do we report this? And this is text that if you use this on the notes page that I had uploaded for you, this is the way that if you're writing up a t-test that you would report it. So you might say something like, overall, Pikeland Pils tastes better than its two main rivals, Coors Light and Bud Light. The t-test, and then this is how you'd report the t-test. It looks a bit awkward, but that's the kind of information that someone reading it would need to know in order to see. It's kind of like when you're doing maths when you're a kid and you had to show your work. That's kind of what this is. It's showing your work. So the T, the 4.07, P is less than 0.00. The t-test confirms that consumers prefer the taste of Pikeland Pils, and here you report the mean, significantly more than they like Coors Light. And you put the mean and the standard deviation in. The t-test also found that they, favored Pikeland Pils to Bud Light. Now, since your question was about whether or not they liked Pikeland Pils versus the other two, even though you ran it on the Coors versus the Bud, you're not interested in that because it's not helping you to answer your question. So this is what you end up reporting. When you're doing this kind of a summary, this is what would describe what your test was and what you found. You're giving the reader all of the essential data, but you're also explaining it in plain language. If you take out the numbers in there, that's fairly simple language that you're using in order to describe it. There shouldn't be anything super fancy or super confusing about the way that we interpret and explain the data that we find. As a matter of fact, when you take the numbers out, it should read like a fairly ordinary paragraph. Now, the word significant, that's the key word when you're talking about statistics. We don't talk about significant findings unless the p-value is less than 0.05. So when you're reporting data, that's something important to keep in mind. Don't be creative with the language, but also don't use the word significant unless you're talking about something where the test demonstrated statistical significance. So, as just a brief introduction to t-tests, that hopefully gives you a bit of a context for doing them. So I'm going to close that out. And then I'm going to pop open to our data. So when you open up the data, this week's data, I have gender, age, household income, region, and then their monthly spend, what people estimated that they spent on groceries in the last month, at all of these different grocery stores. So for your homework this week, you're going to be looking at a couple of these comparisons to do. So on your homework, let's actually take a look at that really quick. So your objective for the homework this week is to evaluate how good the data is in terms of how well it represents the overall population, and then to see if there are significant or meaningful differences. So your step one is to look at the frequencies, and we'll do that just in a moment. So you run the frequencies test, and it's with analyze, the descriptive statistics, and then frequencies. We'll do that in the demonstration just in a moment. Then step two, I would like you to go on to the Office of National Statistics information for income and population, and I've given you the starter link. If you type in for income first and then population, you'll find the basic statistics and use the latest year. I think 2019 for both of them was the latest reporting year for it. And so this is just a comparison. You're going to have your results, and so I'm asking you to think about it in terms of income and in terms of region. Have we represented the data well? Then in the third step, you'll run a paired simple t-test comparing people's monthly spend from Lidl, from Morrison's, and from Asda. So what we are going to do today for the demonstration is to go through both of these just with some different variables. So we'll minimize that, come back into our data. So what we'll take a look at in the demonstration is we'll take a look first at gender and age. So again, if from this very top menu, the Analyze, if you click on that, then you go down to the descriptive statistics, and that will bring up the box where you can look at frequencies. I like the frequencies better because it gives you more options than any of the others. So click on frequencies, and you will get this box that comes up. So right now we're only interested in gender and age. So gender is already highlighted because it was the first one. Then you can hold down Control if you're on a PC or whatever it is that you hold down on the Mac to also highlight age. Then using the little arrow button in the middle, like we did last week, you pop them over into the right-hand box under Variables. Now again, less is more in SPSS. Don't choose a lot of different options. So all you really need to do is under Statistics, click on that top button for Statistics, and for the most part, what you're interested in is the mean, the standard deviation, and then also put in the minimum and maximum just as a point of interest. So you can start to see some of the different information that gets reported. You click Continue, and then you click OK. And we'll maximize that. So in your output file, you get a table that looks like this. This very first box that says Statistics, these are the summary values. So you can see that there are 2 people who didn't put in any answer. That's what the missing is. You can disregard that. But we had 782 respondents who answered this question for both of them. The mean gender was 1.51. So what do you think that means, a 1.51? Given that, and this is also useful when you look at your data. If you can't remember on categorical data like this what the 1 and the 2 were, this is why you want to have under your values, if you go back into the variable view of your data and you see this values column. It's worth having a note, so you can left click anywhere in there to bring up this little box. If you need to double check your values of what they are, you can do that right here. So for male and female, 1 happens to be assigned to male, 2 happens to be assigned to female. Because it's categorical data, it doesn't matter which number you put. So you keep that in mind when you're looking at your average. So you go back to your output. A 1.51 actually tells you had about the same number of men and women. So when you look down here go to the frequency table, and for gender, you have male. There were 383 participants who were male, so 49%, and 399 who were female, so 51% basically. So that tells you had a fairly even distribution between men and women. Now, the question you'd want to ask is, overall UK-wide, does that roughly represent how many men and women there are? And yeah, there's usually, in most populations, there's slightly more women than there are men. So that makes sense. And then you can take a look back at the top box. The minimum was 1, the maximum was 2, because that was the only option that there would be. So that's how you read those two tables in together. Now, for age, 4.01 seems like a strange number, and it's because I had them do them in categories. So I was interested in generational looks. So we go back in to our data file, the variable view, and we only allowed people to respond who were over 18. So we had categories from 18 to 24, 25 to 34, 35 to 54, 55 to 64, and then 65 and over. So in doing that then, having a mean on our output of 4.01 tells us that most of our, that on average, people were somewhere in this category. So they were somewhere between 35 and 54, with a few more folks 55 and over. But for the most part, on average, we would expect the majority of people in a population to be this in the middle age category, which is also slightly depressing when that includes me. So we can see then how many people were actually in each of these categories from our respondents by looking at this very bottom box. So you look at age, you can see 72 in the 18 to 24, and the percentage there. So this gives you a sense then, if you're looking at it, you get both the percent as well as the frequency. Now, the percent versus valid percent. You'll want to use the valid percent because it takes into account the missing. So notice down here at the bottom left, it says the number of missing. And these were the folks who were under 18 who clicked on the questionnaire and responded. They got booted out as soon as that question was asked. They were thanked for their time, but that we have to have participants who are over the age of 18. There were 2 participants who were in that category. So they represent 0.3 of the population. So the valid percent gives you, of the total who actually could complete the questionnaire, how do those numbers relate? So 72 people translates into 9.2 valid percent of the respondents for the questionnaire. So when you're looking at those, you look at the categories, the frequency, and then the valid percent. So once you have a sense of how representative your sample is, then you can get into the testing. So for your homework, you're going to look at Little Morrison's and Asda. For this, let's do a t-test to compare M&S, Aldi, and Tesco. So again, we go up to our very top where it says Analyze. We click that. We go down to the Compare Means and over to the Paired Samples t-test. Because we're comparing two different variables, we want the Paired Samples t-test. And we click that. And expand that so we can see it a little bit better. It doesn't matter which variable you put in as variable 1 and variable 2. What this does, so we're comparing M&S to Tesco in the first case, because you can only compare two at once. So it doesn't matter which you put in, you highlight it, you click the middle arrow, and it pops it over. You want to be systematic though about it because it's only comparing two, and you want to compare three. So I put M&S in first because it was at the top of my list. So you go M&S again. We've compared it to Tesco already. Now we want to compare it to Aldi. And we put that over. So now we have the comparison between M&S and Tesco, M&S and Aldi. Then we need the third one that isn't yet compared, which is Tesco to Aldi. Now, you could do this with as many variables as you wanted to compare. You could just do two comparisons if that's all you were interested in, or you could do all of them. It just takes a lot to get through all of them, so we didn't really want to have more than just the three. Now, the nice thing is we don't need to select any other options. In the t-test, once you have variable 1 and variable 2, and you're making sure that you have all of your comparisons that you need, you're ready to go. So you click OK. Now, as always with SPSS, there are tables that you don't need in your outcomes. This paired samples correlation, the middle table, you can highlight that and delete it, because that's not telling us anything that we're interested in. We're asking the question, is there a significant difference between the amount of money that people spend monthly at M&S, Tesco, and Aldi? So we can take a look first at the means. So on average, our respondents spent £15 a month at M&S Simply Food, £72.55p at Tesco, and £32.49p at Aldi. And you see those means listed multiple times in this first table because that's for each of the comparisons. So that's the mean that you would be reporting. You'd only report it once because you only need to report it once. Then you can see the N is the number of participants. So there were 784 people who answered this question. And there was a considerable amount of deviation with this. Again, that makes sense. People from different sized families. You're not looking at anything that would be quite strange. You report the standard deviation, but you can ignore it, and for now you can ignore the standard error of the mean. That's not giving you anything that you guys would need. So then we look at our paired samples t-test. So when you're looking at this, our p-value is on the far right-hand side. This is where I like to start, is to look at the significance two-tailed. The two-tailed just means that it's testing both as it goes up, as the number goes up, and as the number comes down. And we want those numbers to be less than 0.05, and guess what they are? They're delightfully different. Now, of course, you can look at those numbers, £15 versus £32 versus £72. But this is giving you a really nice picture of how big. So you start with the significance, that it's strongly significant, And then you see the t-test, the t-value, which is our test value. And so for the M&S versus Tesco, that is quite a large number, the negative 14.554. The positive and negative you report. In this case, the negative only means that your smaller number was first. So it looked at the difference of 15 pounds to 72. So it's just, that's all the negative number right now is telling you, is which number, the bigger number or the smaller number that you put in. You still report the number, but you don't worry about the positive and negative. You report that it's a negative 14.55, a negative 6.63, and then a positive 8.89. But that's all that the positive and negative number is telling you at the moment. Now, all this is telling you is that there is a significant difference. If you think about the possible explanations for what that significant difference might be, this test isn't telling you what that might be. So, for example, this doesn't tell you that people like Tesco more. This doesn't tell you that people buy more things at Tesco. All this is telling you is the amount of money that people spend at Tesco is significantly different, and in this case, when you look at the mean, more than the amount of money that they're spending at either Aldi or M&S. This also tells you that the amount of money then that the people are spending at M&S is significantly less than the amount of money that they're spending at Tesco and Aldi. It's really important, though, that you don't overclaim the differences between the two, or what the differences mean. So you can't make any claims about favorability or likability or even which one is the better value, because you would need additional tests in order to do that. This is just telling you what the significant differences might happen to be. Now, in this case, these numbers are all pretty different, but you can play around in the data, and I would encourage you to go beyond just the Little Morrison's and ASDA comparison that you guys are going to make for your homework to try and look at maybe means that are very similar, and to see, at what point is there a significant difference between the two. Any questions about this paired samples t-test? So when we go into this week's assignment and the material for this week, what I wanted you to highlight are a couple things. First, this first podcast that I hope you guys have watched already, but if not, make sure that you do. The biggest point that I want you to get out of this podcast is that it's a nice introduction to the different reasons that we run different tests. Each of the weeks, we're going to be covering a different test or a different set of tests. But one of the critical decisions that everyone has to make is, what test should I run at what point? So when you're trying to figure that out, it's about the type of question that you're going to ask. So the t-test looks at, are there differences in comparable means, like we've been talking about? But that doesn't necessarily say, is this different for men or women? Is this different based on age, based on income, anything like that? We'll get to those in coming weeks, actually. But so what we're doing with these tests is we're layering on what we can do to analyze them from the simple to the more complex. So making sure that you have a good handle on the simple and what types of limitations there are in terms of the questions that you can ask and the data and conclusions you can draw from those is an important point to try and make sure that you're getting a good sense of what you can accomplish with each test and where you might need to choose different types of tests. Also, this information is in the running paired sample t-test with a different example if it's helpful for you to see. After we're finished and if there aren't any questions and discussion at the end like we had last week, whenever we're wrapped up, what I'll be doing under the Wednesday live session is just like I did last week. I will get the YouTube video as it's finished, and I will link that in here so that if you need to go back, or for the folks who aren't in it. Also, for folks who weren't here, you can go to the Skype session and see the conversation, see any questions that there were. Then your assignment, make sure that you download the guidance there. And then when you're ready to do the assignment, one thing too is if you can work on this with other folks, of course. You can also redo this as many times as you want up until the final assessment date. So in this case, even though it's due on Friday, you'll have until the 17th of April to submit it without any kind of penalty. So if you need to redo it, you can. There's no hassle. It just overwrites each time that you do. Any questions about any of that? What I'll do is I will stop the live session now for YouTube.